Hello, we continue our discussions on this chapter 4 on heat. Okay, questions number 33. So in these questions we have an air bubbles released by a diver. Volume is given. Okay, it's 4 cubic centimeter, depth 15 centimeter, and we are to find what is the volume of the bubble at a depth of 10 meter. Okay, I missed my H here. Okay, of 10 meter. So what do I have here? Okay, I have a surface of water, and then I have air bubbles down here. The distance from the surface to the air bubbles, it is 15 meter. And then the volume, okay, I put here V1, that would be 4 centimeter cube. And then okay, I notice here that my atmospheric pressure is given in 10 meter of water. Alright, so I have P atmosphere pressing down. Okay, so here I have P atmospheric is 10 meter of water. Therefore, my pressure P1 here, okay, I have 15 water here, and then up here I have 10, so that will be 10 plus 15, so I have 25 meter of water above that point. And then what is the volume of the bubble at the depth of 10 meter? And what if the bubble is here, alright, whereby the distance is 10 meter? What is the volume? So I'll use V2 for the volume. This is what we want to find out. And then my pressure 2, that would be 10 meter of water there, plus the atmospheric pressure, which is also 10. So my pressure at point 2 is 20 meter of water. So next, okay, we are going to apply our universal gas law. That will be P1 V1 over T1 equals P2 V2 over T2. Alright, do I have temperature in the questions? No, right? So we assume temperature to be constant, so we can cancel the temperature out. Alright, so now let us substitute the value of P's and V's into our equation. So P1 is 25, okay, P1 is 25, and then V1 is 4, okay, equals to P2 is 20, and then V2 is what we want to find out. Alright, so I only have one unknown in this equation, so I can find my V2. So V2, if you do your calculation, you should be able to get 5. 5 what? You see my volume here is in centimeter, so this one here, it must also be in centimeter cube. So that is the volume of the air bubbles when it moves up until the depth is 10 meter. Okay, let's move to question number 34. Before a journey from Selangor to Konawe, the air in the car tire has a pressure of 200 kilopascal and a temperature of 27 degrees Celsius. And then after the journey, the air pressure becomes 220 kilopascal, and we want to find out what is the temperature of the air now. Alright, so I have my P1, that would be 200 kilopascal, and then my temperature 1 is 27 degrees Celsius. And remember that in gas law we do not work with temperature in Celsius, we work with the temperature in Kelvin. So we have to convert this degree Celsius to Kelvin. How do we do that? Just add 273. Okay, so this will give you the temperature in Kelvin. That will be 300 Kelvin. Alright, and then my pressure 2, that will be after the journey. My pressure 2 now is 220 kilopascal. And I want to find out what is the temperature now. Right, this is our unknown. Okay, so now we apply our universal gas law, which simply says that P1 V1 over T1 equals P2 V2 over T2. Okay, in the questions I don't have my V, so we assume my volume to be constant, so we can cancel volume out. Okay, so now let us substitute the value of P's and T's into our equation. So P1 I have 200 kilopascal. The temperature is in Kelvin, that will be 300. And then my P2 is 220 divided by my T2. Okay, so now I can find my T2. My T2 happens to be 330. Okay, 330 Kelvin. Okay, so what is this in degrees Celsius? So to convert to Kelvin, we add 273. So from Kelvin to degrees Celsius, we deduct 273. Okay, so that I can write my temperature in degrees Celsius. That will be 57 degrees Celsius. Okay, can you follow? Alright. Let us move to question number 35. So diagram 35 shows an arrangement of the apparatus, okay, used to investigate the relationship between pressure and temperature of a gas at constant volume. Alright. So what is the functions of the Bourdon gauge? Well, Bourdon gauge connected to our round bottom flask, okay, being heated. So we are measuring the pressure inside this flask. So what is inside the flask? The air is inside the flask. So what is the functions of a Bourdon gauge? That is to measure gas pressure. And in this experiment, our gas happened to be the air. So it's the air pressure. Alright? So that is the functions of a Bourdon gauge. And then we go to the next question. Diagram B and C shows the pressure temperature graph. So in diagram B, I have pressure against temperature in degrees Celsius. In diagram C, I have pressure against temperature in Kelvin. Alright, so remember our universal gas law. Okay, it's P1 V1 over T1 equals P2 V2 over T2. Okay, so from this universal gas equation, okay, I can rewrite this as P V over T equals constant. Okay, the value of pressure multiplied by the volume divided by the temperature is a constant. Okay, I can also write here to be P3 V3 over T3 until an n value Pn Vn over Tn. Alright, so what is the relationship between pressure and temperature. So I can rewrite this. Okay, I can write PV equals CT. Remember that C is a constant. So what is the relationship between P and T? Okay, T increases, then P increases. So the relationship is directly proportional. Okay, so how does the graph looks like? Remember that in gas law, the temperature must be in Kelvin. Okay, so maybe I move to my diagram C first. Okay, I do know that my pressure is directly proportional to my temperature, and this temperature, it must be in Kelvin. Okay, so it's directly proportional. So my graph, it must start from 0, 0, the origin, and it will go straight up. Okay, it's a straight line. But if you are to sketch this on a pressure temperature graph whereby the temperature is in Kelvin, it won't start here. Okay, remember that in order to convert degrees Celsius to Kelvin, I have to add 273. Okay, so that I can convert that to Kelvin. So 0 Kelvin, that will be equivalent to negative 273. So my graph will look like this. Okay, it will cut the x-axis here at negative 273 degree Celsius. So that's how my graph looks like. Okay, if I am to plot pressure against temperature, whereby the temperature is in degree Celsius. Okay, now let's move to the next one. Name the gas law that describes the graph shape above. So this is our pressure law, because we are dealing with pressure and temperature. So we have pressure there, so that must be the pressure law. Okay, now D. The trapped air pressure in a flask is 120 Pascal. The temperature is 27 degrees Celsius. What is the pressure if the temperature is increased to 57 degrees Celsius? Alright, so my P1 is 120 Pascal, and then my temperature 1 is 27 degrees Celsius. Remember, we don't work in Celsius, we work in Kelvin, so I have to add this 273 to it. So my temperature 1 is 300 Kelvin. And then P2, okay, is what we don't know, but my T2 is 57 degree Celsius. Again, convert this to Kelvin, so we add 273. Okay, so my T2 is 330 Kelvin. Alright, so next we apply our universal gas law equation. P1 V1 over T1 equals P2 V2 over T2. Alright, so in the questions, I am not given anything or any info on the volume. So we assume volume to be constant, hence I can cancel my volume out. Okay, P1 is 120, T1 is 300 equals P2, we don't know, and T2 is 330 Kelvin. So now we can calculate our P2. Okay, so my P2 here is 132 Pascal. easy, right? Okay, so let us move to question 36 now. I have air bubbles produced by a pump in an aquarium, okay, from Q to P at a depth. So I can see here at a deeper depth, my bubbles is smaller. As it goes up to the surface, my air bubbles become bigger. Okay, what is meant by pressure? So remember that the general equation for pressure is P equals F over A. Okay, that is the general uh, equation for pressure. So from this pressure, you will get uh, rho GH and whatever, right? So what is meant by pressure? So pressure is, okay, so pressure, we write pressure is force per unit area. Okay, and I would like to remind you that our force and the area, they must be perpendicular. Alright, it is not the first time that I remind you about force and area being perpendicular to each other. Okay, let's move on. Based on the diagram above, compare the water pressure at level P and level Q. Okay, you are to compare water pressure. Okay, so we write the quantity to be compared. So I have water pressure. Okay, so water pressure at Q is what? So Q is down here, right? So it being pressed by the water and then being pressed by the atmospheric pressure. But P here it being pressed by the atmospheric pressure only. So which one is greater? So definitely Q is greater, right? So here water pressure at Q is greater than that of level P, or than that at level P. Now, compare the volume of air bubbles at P and Q. So the quantity to be compared would be the volume of the air bubbles. So we just write the quantity that we are comparing. So that would be the volume of the air bubbles at, oops, okay, at Q. So I try to be consistent here. Okay, up here I'm doing it with respect to Q. So I'm down here, I'm going to use Q, okay, as well. So the volume of the air bubble as Q is what? At Q would be smaller, right? Smaller or less than that in P. Okay, follow? You can also use the term like lower lah, no problem. Okay, relate the pressure exerted and the volume of air bubbles. Okay, pressure exerted, that will be pressure here. And then for the volume of air bubbles, okay, the volume of air bubbles. So you can see here, Q greater, okay, pressure greater, and then the volume of the air bubbles is lower. You see that? Okay, so here pressure is greater, and then what happened to the volume? Volume becomes lower. Okay, that's why I try to be consistent when I choose at which point. So I'm choosing point Q. So now I can write the higher the pressure or the greater the pressure, the lower the volume of air bubbles. Okay, try to understand what we are doing here. Okay, next question. Name the physics law involved in B3. So in B3 here, we are talking about pressure and volume. Okay, pressure and volume. So what physics law is that? That would be our Boyle's law. Okay, so if we go up, okay, we go to page 15. Okay, so pressure and volume, okay, pressure and volume, that will be Boyle's law. Volume, temperature, that will be Charles' law. And then pressure, temperature, that will be our pressure law. Okay, so for the question just now, we have pressure and also volume, right? Okay, for these questions, I have my pressure and volume. Okay, see here, pressure and volume. So that is our Boyle's law. Alright, let's go to the next one. An air bubbles of volume 5 cubic centimeter released by an air pump at a depth of 0.5 meter. And then calculate the volume of the air bubble when it reaches the surface of the water. Okay, no problem. So I have here the water surface, and then I have the air bubbles here. Okay, the air bubbles here, the volume at that point, okay, V1 is 5 cubic centimeter, and then the depth is 0.5 meter. Okay, so and we are also given that the atmospheric pressure is 10 meter of water. So what is pressing these air bubbles? Okay, so what is pressing the air bubbles is the water above it. That will be 0.5 meter of water. And then if we go further up, we have the atmospheric pressure. That is 10 meter. So the pressure acting on the air bubbles is 10.5. Okay, meter water. And then at the surface here, okay, the volume is what we want to find. And then what is the pressure at that point? So who is pressing the air bubbles at the surface? There's no water above it, it's only the atmospheric pressure, right? So it's only the atmospheric pressure is pressing on the air bubbles. So my pressure at point 2, that will be 10 meter of water, equivalent to my atmospheric pressure. Alright. So next, I am going to apply my universal gas law equation. There will be P1 V1 over T1 equals my P2 V2 over T2. So in this problem, I don't have any temperature, so we assume the temperature to be constant, so we can cancel our temperature out. So next, we substitute the P's and the V's into our equation. Okay, P1 is 10.5. V1 is 5 cubic centimeter. And then P2 is 10. And V2 is what we want to find out. So I believe now we can calculate our V2. Okay, so V2 is 5.25 cubic centimeter. My 5 looks like 6, right? So I will rewrite my volume at 0.25.25, okay, cubic centimeter. Okay, try to follow what we are doing here. Okay, so we simply use our universal gas law to solve this gas problem. All right, so we go to the last questions. Okay, before traveling a long journey, Lokman measured the air pressure of the tire of his car as shown in diagram A. He found that the pressure was 200 kilopascal, and then after the journey the pressure became 245 kilopascal, and at the same time it also found that the tire becomes hotter. All right, so initially I have here pressure is 200 kilopascal, and then here is my P1, and then after the journey I will write that as my P2. My pressure become 245 kilopascal, and then the temperature 2, okay, is greater than my temperature 1. In other words, my temperature increases. So I need to find what is the relationship between pressure and temperature. Okay, so for this question, you are to design an experiment. So just keep this in mind. I am going to investigate pressure and temperature. All right, so what is a suitable inference and hypothesis, okay, for this case? So remember that inference must be based on the diagram. Okay, I repeat, inference must be based on the diagram. Hypothesis onwards, it must be something that you can run in the lab. Okay, so what is a suitable inference for this diagram? Okay, for this scenario. All right, so we can write A pressure depends on temperature. Okay, so remember just now that we are talking about our pressure and also our temperature. All right, so that's why I have my pressure and then temperature. So the keyword for inference is depend. All right, I can also write here the air pressure in the tire depends on the temperature at constant volume. Okay, so remember that the inference must be written based on the diagram given, but the hypothesis onward, it must be something that you can do in the lab. Okay, so we have written down our inference just now that air pressure depends on the temperature. What is the hypothesis? Okay, so the hypothesis here, I can write the greater the temperature, the greater the air pressure. Okay, at constant volume. So remember our PV over T, okay, is a constant from our universal gas law. So the pressure and also the temperature, so I can write PV equals CT. When temperature increases, then my pressure also increases. So they are directly proportional, right? So I do know that the greater the temperature, the greater the pressure. Alright. So suppose that I write here, the greater the temperature, the greater the air pressure in the tire, for example, at constant volume. So can I write this as my hypothesis? So the answer is no. Why? Because we don't have car tires in the lab, right? So this one cannot be written here. So I repeat that the hypothesis onward, hypothesis and variables, okay, hypothesis onward, it must be something that you can do in the lab. Alright, and now aim. So for aim, we always write this one here to investigate the relationship between, okay, between what? Okay, between the variables that you have mentioned in the hypothesis. The variables you mentioned is the temperature and the air pressure. So temperature and pressure. So for the aim, it must be to investigate the relationship between the pressure and the temperature. Okay, it's okay if you don't mention at constant volume, but it's better to mention though, because we are talking about gas law. So for gas law, it's always about pressure, volume and temperature. Okay, so what are my variables? Okay, so my manipulated variables and my responding variables, so these two refer back to my aim, okay, and it also refer back to my hypothesis. So between pressure and also temperature, which one is your manipulated variables? Okay, so if I write my temperature as my manipulated variable, then pressure must become my responding variable. Okay, I can control my temperature. Okay, so that's why I write my temperature as my manipulated variable and pressure as the responding variable. So pressure can be read from a pressure gauge, right? And what is my constant variable? So in this case, remember that we are talking about gas law. Is always about pressure, temperature, and also volume. So I have mentioned temperature and pressure up here. Then the volume must be kept constant. Alright. So next, we go to the list of apparatus. Okay. So if you don't know what are the list of apparatus, you can try to draw first. Okay, so actually this is a diagram that you have seen earlier on. Okay, it is this diagram here. Hold on. Okay, this diagram here. Okay, I have here heating up, so I have temperature read by thermometer, and then pressure read by my Borden gauge, right? Okay, so since that I want to know what is the relationship between temperature and pressure, right? So for pressure, I need to have my Borden gauge, and then for temperature, I need to have my thermometer. Okay, so to increase my temperature, I need a Bunsen burner. Okay, so I can have this, the one in green here, but we normally don't do this because it's a bit dangerous, okay, to heat up air. Alright, so instead of doing this, I put it in a water bath. Okay, so I have my Bunsen burner here. So this Bunsen burner will heat the water, okay, and then this water bath will heat the air inside this flask, okay. Okay, follow? So the pressure inside here will be increased and it will be read by my Borden gauge. Okay, so from this apparatus setup, I can now list my apparatus. Okay, so what are the apparatus and material that are compulsory? So remember that in our variables, okay, I'm going to use notation whom and papa. So our manipulated variable just now is the temperature, and then our responding variable is the pressure. So how do you read temperature? How do you measure temperature? Okay, you must have a thermometer. How do you measure pressure? Pressure is measured using a Borden gauge, right? So you must have Borden gauge in the list of apparatus and material. So these two are the compulsory apparatus and materials in the experiment. Okay, other than that, okay, since I have a thermometer, thermometer will read temperature, okay, and then to increase the temperature, I do need a Bunsen burner. Okay, so this thing here is also considered, uh, can be considered compulsory item, but the two compulsory item in the experiment is the thermometer and the Borden gauge. Alright, so next let's go to the procedure. So the first sentence here is the same for all experiment. So the apparatus is set up as shown in the diagram above. Okay, the next one here, okay, the next one here is how you control your manipulated variable. So your manipulated variable is the temperature, right? So I need to have a first value. Okay, the first value of my temperature, I choose 40 degrees Celsius. But how are you going to write this in the procedure? So I can say heat the water bath, okay, while constantly stirring it until the thermometer reads 40 degrees Celsius. So my verb here would be heat and then read. Okay, read what? Read the thermometer. Heat what? Heat the water bath. Okay, so that's how I control my manipulated variable. I start with temperature equals 40. And then for the third procedure is how do you measure your responding variables. So our responding variables here is the pressure being read on the Borden gauge. So for procedure number 3, for step 3, I just simply record the reading of pressure on the Borden gauge. Okay. The word record here is compulsory. Okay, so my responding variable is the pressure, and how do I measure pressure? I use a Borden gauge. Right, so remember the word record here is compulsory. So that is step number 3. And then the last step is repetition. Okay, so I will just simply repeat step 2 and step 3 for temperature. Just now we start with 40, so now I increase to 50, 60, 70 and 80. Okay, so how many data down here that I am repeating? 4. 4 values of temperature plus our initial values, so I have 5. Okay, so for temperature I have 5 values. This is a must. You must have at least 5 values of your manipulated variables. You cannot have 4. You must have at least 5. Okay, follow? Okay, now we go to the data tabulation. So I have my temperature and my pressure, and these are the values. Okay, you see here I have 1, 2, 3, 4, 5. Okay, you must have 5 values of the manipulated variables. Alright, so I don't have to fill up the pressure here because you haven't done the experiment. Just do it like this. Alright, I have my table drawn. The header is written temperature and pressure. Okay, and then the values of my manipulated variable, which is the temperature, is also written in the table. And lastly, how do you analyze your experiment? Okay, the data analysis. So I'm going to plot a graph. Okay, a graph of pressure against temperature. That's it. No need to draw how the graph will look like. No need. Just draw an empty x and y axis. Alright, whereby my variables are stated in my axis. On my axis. So in this case, my variables are pressure and temperature. So you must write pressure, temperature on the axis. Alright, so we are done discussing chapter 4 on heat, okay, of form 4. So after this we are going to cover chapter 5 form 4, that will be on lenses and mirrors. So we'll meet again next time. See you.